Now let's look at some examples of expanding log expressions. So the first thing to remember is that we have three rules about log algebra, or properties of logs. The product rule, that is multiplication is like addition. The quotient rule, that is division, subtraction. And the power rule, which equates raising to a power to multiplication. And so an example would be that you would give a problem like expand log 3 81x squared. So what you need to do here first is that would be log 3 of 81 plus log 3 of x squared. Now notice here when you start, the x, the squared term there, only goes with the x. It doesn't refer to the 81. And that's important when we check our answers later. So now we have multiplication is like addition. So now we have powers. Powers is like multiplication. So we have the third log of 81 plus 2, the third log of x. And in this case we can actually simplify it because the third log of 81 is simply 4. And your final answer would be 4 plus 2 log 3 of x. And there's an example of expanding. Let's look at a slightly more difficult problem. Let's look at ln x cubed over 5y. Now you're working backwards here, so you remember your PEMDAS rules, but when you're thinking about order of operations, the division bar is always the last, so when you undo it, it's always the first. So the first thing I'm going to do is I'm going to go ln x cubed minus ln 5y. And what I want to notice here is that the 5y, both the 5 and the y are on the bottom, so the negative sign is going to go with both the 5 and the y. The next thing I do is here I have multiplication, so that's going to be ln x cubed minus ln 5. The 5 and the y, that's ln 5 plus ln y, but there's a negative out in front, so that's minus ln y. Since that's a little more difficult, I'm going to make sure I got that right. The 5 has a negative in front, and the y has a negative in front, so both of these should be on the denominator. So let's look at the denominator, and there's both the 5 and the y, so I did that right. The last step would be the power. The power, we bring the 3 in front, so we have 3 log x minus and 3 ln x, ln 5 minus ln y. Now the ln 5, you could do that on your calculator. Whether you do or not is sort of a matter of preference. If we did ln on our calculator, we get ln of 5 is about 1.609. So our final answer would be 3 ln x minus 1.609 minus ln y. Since we used a calculator and rounded, that makes that into an approximately equal. Let's do one more slightly more difficult problem. Let's say you have the 7th log, the cube root of z over y. Let's say the cube root of z squared over y to the 4th. The first thing I'm going to do is I have the division bar, so I'm going to do that. Well, actually, the very first thing I'm going to do is I'm going to take cube root, I'm going to make that into a rational exponent. So I'm going to go, that's log 7 z to the 2/3 over y to the 4th, and I'm going to start from there. The division bar I do first, so that's log, the 7th log of z to the 2/3 minus log 7 y to the 4. Why the minus? Because it's division. Division equates to subtraction. I don't have any multiplication here, but I do have power, so I'll bring that in front. So that's going to be 2/3 log, the 7th log of z minus 4 times the 7th log of y. Make sure that I can't expand that anymore. I'm done. So there's my answer right there. I've done 3 examples of expanding log expressions.